A general question in stellarium, when you do ocular view and put the details of the telescopes and all, the view which you get by stellarium, how much is true with the real observation?
I have no idea. I'm hoping someone else can answer that.
I can answer that question if it's okay. So, like, I mean, there's only one good answer to this question, and the answer is the lawyer's answer. It depends. So, in a lot of cases, right, it will show you objects that are supposedly visible, but a lot depends on your sky conditions also. And you will not see the exact same details that you see in stellarium. Stellarium is very optimistic, the ocular view that you get, but it does help you in getting a feeling for what you can see in the eyepiece. That's pretty much it.
Okay, because I have this Leica 77 with Barlow, and it's 800 then focal length. I was not able to see, as per stellarium, should not be able to see Saturn rings.
Oh no, so okay, I'll just say this quickly and then I'll let Akarsh take over.
Yeah.
So don't let anything that you read on the internet or any program tell you what you can and cannot see through your telescope.
Yeah.
The only thing that you can really depend upon is your own eyes and confirmation. I'll let Akarsh take over though.
Yeah, thanks.
But that is a bit surprising though, that you mean, Ajay, it's not seeing limited, but like the magnification is insufficient. Is that right?
Yeah, stellarium seems to do some interesting computations around the magnification, etc.
I see. Yeah, I haven't used stellarium enough, so that's why I wouldn't know exactly on that. Okay, so let me quickly recap last time. We went, I think last session was probably the most practical and kind of heavy session on deep sky observing, where we covered various techniques for visual observing and for various kinds of objects and so on and so forth. So there were two items from that train of thought that we hadn't, or from that subject that we hadn't finished, and so I will go on to them shortly. But I want to ask before that if there were any other questions from last session. Okay, so then I'll move ahead, and again we'll have some more time for questions after this bit is over. So this is where we stopped last time, and so now we'll talk about we talked about nebulae last time and ended there. So we talk about dwarf galaxies and faint globular clusters. I think the difference between observing low surface brightness nebulae and low surface brightness globular clusters and dwarf galaxies is not much difference. It's much different. It's all just low surface brightness kind of techniques. So sky conditions and contrast is going to be everything. I don't know how much I could swear by this word, but aperture is, I don't know if I believe in this, but the aperture doesn't seem to be as important as sky conditions. And somehow even smaller telescopes will surprisingly produce views of these objects in the right sky conditions that are challenging even for larger telescopes. So aperture doesn't give you a big advantage, and we already discussed this when we went over low surface brightness a long time ago. And a well-baffled refractor, you know how refractors have very good baffling. A well-baffled refractor like a Takahashi might actually challenge a big dog on some of these observations. And I still don't fully understand why. I think Mel Bartels probably does better. And I think he has seen that the fastness of the telescope matters. I think we already mentioned this also a couple of talks ago. And just like with big nebulae, sometimes the object is just so diffuse that you only have to map the transition between the background brightness from sky background to sky background plus object and you only trace the outline. I remember this being the case with Ursa Minor dwarf, which is one of the really hard dwarf galaxies. But on the night when I attempted this, the sky conditions were so good that I was able to map some of the edges. I think it's one of the 2 or 3 best nights in my entire observing time. So we've already said this, sky conditions matter a lot for this. And if you have great skies, that's when you should be looking at low surface brightness objects. So that's it. It's the same thing. The other interesting thing is observing at high power. So when you're observing extremely tiny objects, usually many of the ARP galaxies are like this, ARP interacting pairs, or galaxies in faraway clusters, or even extreme objects like Einstein's cross. You're usually going to rack on powers more than 400x to actually magnify these objects sufficiently big. And then seeing becomes a problem. So because of atmospheric seeing and atmospheric turbulence, so for those of you who don't know what seeing means, it's a word used by astronomers to describe the quality of atmospheric turbulence. If the atmosphere is steady, then the light doesn't refract randomly, and so your stars don't twinkle, and the observing is good. For when you're observing at high power, so normally you think of seeing when you're observing planets and looking for tiny detail in planets, but even for deep sky objects, when you're observing at high power, seeing is very important. So observing at high power is like watching a video that is continuously being blurred in a random way. And so it can so happen that you are up at the telescope and you see a feature clearly, and 2 minutes later, you just cannot see it at all. So this can happen because the seeing conditions change so quickly. So you need to catch the few instants of the steady air, and views may pop in and out. So sometimes we have seen situations where somebody is at the ladder and they're describing this amazing thing. The next observer goes, even if they're extremely experienced, they might not be able to see as clearly simply because the good seeing has vanished. And then somebody waits for a little more time and then it comes back. So examples of things that need great seeing are, Mars polar ice caps. Almost all detail on planets needs very good seeing. Then there are objects like Einstein's cross, which is a very challenging observation. I'll talk about it. And the jet of the quasar 3C273. These are for very big telescopes. But even in 18, 20-inch kind of aperture ranges, you will put on enough power sometimes that seeing makes a huge difference. So this should be borne in mind when you're observing at high power, that things are going to randomly change depending on how steady the air is. And of course, fans help. We have already discussed this, and the tube currents should be avoided. Okay. So that finishes our observing chapter almost. We'll talk a little bit about logging. I'm not the best at writing logs or making sketches, but there are people whose logs I'm showing here who are very good observers. So first of all, why log? Logging is very useful. I don't remember most of my observations, and the only way I can figure out what I observed or remind myself what I observed is through logs, by looking at my old logs. And logs also make you a better observer, because when you are observing on the field, they prompt you to see more detail. Just because once you get into the habit of logging, you will start to make it a point to see more detail simply because you have to fill that in your log. And especially if you're doing sketching, where you want to be as accurate as possible to what you see. And I still don't know how to organize my logs. My logs are not at all organized. So if you're starting in this hobby, please find a way to organize your logs very well. Most of my friends who do visual observing take logs with pen and paper. They sketch with pencil on white paper, and then they digitize their logs manually. I didn't want to do this, so I started taking logs on a tablet, but then they're still not searchable, and it's actually harder than flipping the pages of a book. So I am looking into a solution to this in the form of this remarkable tablet, if any of you have heard about it. But even otherwise, just paper observations with a proper index that you scan and keep for posterity is helpful. If anything, if I have to learn anything from my past, it would be that I should keep them in one place and keep them more organized, and so that all the observations are traceable. I've lost a lot of my old observations because those books are gone somewhere, or I just jotted something on a sheet of paper because I didn't take my observing log to the field. So logging is very useful and very important. Here's a log by Steve Gottlieb. Steve Gottlieb's observing logs are some of the best in terms of verbal descriptions. He puts so much description into his logs that he almost paints a picture, if I may say. He makes a sketch in words, if I may say so. So here's his log on a good planetary nebula. I think this one is the one in Hercules. So you can see he has details of which powers he observed it at, what telescope, what date, and then he makes these visual measurements of how far something is, like the near stars and what the size of the envelope is, and so on and so forth. And he later compares them to the known size of the object so that he gets the exact numbers. So when he's on the field, he doesn't actually know how many arc minutes it is. He says this is about 1/3 the distance between these two stars, and then he goes in software and looks up the distance between those two stars and converts that fraction into arc minutes, and that's how he gets these logs. Really, Steve Gottlieb has logged I think he has logged more than 10,000 objects by now, and they're all very detailed like this, and he has digitized all of them and put them in a database on software, so he can pull up the log for any of his observations. It's really a work of lot of meticulousness and so on and so forth. So you can see his logs, for example, on Adventures in Deep Space. Okay, sketching. I just am amazed by the way some of these people sketch. This is Howard Banich's sketch of the Trifid Nebula. You can see how much detail he has pulled in. Many of these people who make such detailed sketches, they sketch for almost 2 or 3 nights. They'll spend an hour each night on the object and ferret out as much detail as possible. So I'll show another sketch of Howard Banich later, which is M77, and I believe he did that over 4 nights, spending about an hour each night on the object. But for me, usually I just go with rough sketches. I think so. This is another person who sketches really well, and this is Uwe Glahn. I'm going to introduce these people. Now, this might not be as striking as the previous sketch, but remember, this is a much fainter object. So you might not even be able to see a lot of detail in it. And Uwe has exceptional observing skill. He can see a lot of detail in really small aperture. Seeing this kind of detail in this galaxy in a 16 inches is really mind-blowing. My sketches tend to be much more rough than both of these people's sketches, and you've seen some of them, and I'll continue to show some of them. So there's different levels of sketching, right? So for some of us, it's just a rough note, and for some of us, that's part of our hobby in some sense. And I would say Howard Banich is really strong on sketching. Okay, so that's everything I wanted to say on observing. So before we get on to the storytelling part of this talk, I want to pause and ask if there are any questions.
Hello.
Hi, yes.
Yeah, I have a question.
Yes.
Basically, I see that when we do observation with the eyepiece, then the details are much more clearer. Rather, when we put on some DSLR or some CCDs, then there are not so much details present in. Are you able to understand my question?
No, I mean, usually everyone's experience is the other way, right? That mostly when they take photographs, that's when they get most of the detail. Like cameras are better at capturing detail than our eye, right? So I didn't quite understand what you
Like
mean by this.
for example, when I am taking the photograph of a full moon disk, then
Ah,
so much details of the craters and all are
yes.
not very clearly visible. But
Okay.
rather,
So
when I put on this eyepiece and do some magnification and all, it is much clearer.
so when you're
Wanted to
talking about,
know.
yeah, when you're
Yeah.
talking about the full moon, it's a question of dynamic range. Like the eye has way more dynamic range, so it can see all the shadows very clearly, and you're also able to keep up with the seeing. So for an object like the full moon, there is so much light that when the air is turbulent over in your light path, your brain is automatically processing that video, right? So it's much easier to I think it's easier to see detail unless you stack pictures and you do different dynamic range, like you cover the high dynamic range of the moon, including all
Correct.
the shadows. Uh, so, but when it comes to deep sky observation, you almost never see more detail than a camera can capture. Um,
Correct.
I think there is a way in which you see there is in some sense where you see more detail, and that is because you don't need very good tracking and you
Yes.
don't need very long exposure. The amount of detail your eye can pick up in 6 to 10 seconds, which is its kind of quote unquote exposure time, right, is much more than what I think a good CCD will be able to pick up, especially given that the tracking is not going to be very stable. So in that sense, yes, you see more detail visually, but if with the proper equipment, if you take a photograph, then yeah, the photograph will probably have more detail. Again, unless
Mm.
there is very high dynamic range. For example, in the Orion Nebula, almost every astrophotographer that wants to capture the core and nebulosity has to do high dynamic range imaging.
Okay. So the stacking is the only process by which we can eliminate the condition, right?
There is also adaptive optics, but yes, mostly stacking is at the amateur level. It's yeah, stacking is the way to you would reduce the effects of seeing.
What is the advanced level?
Adaptive optics. It's a technology
Okay.
used mostly in professional telescopes, but it's coming to the amateur world as well. There are few amateur adaptive optics.
Okay.
Yeah, just to add to whatever Akash said. So, yeah, as he said, the dynamic range is the most important thing. So, so when we are imaging, we would, as he said, we would take some short exposures and some long exposures, and then stack them independently, and then try to add all the details from all the different dynamic ranges, so that we can get all the very dim details as well as bright details together. And also, I think what our eye does is kind of lucky imaging, in the sense that if the seeing is bad, and if we are trying to, let's say, observe planets, for example, so we may see some details during some glimpses of time, and our brain actually remembers that. But when you take a raw video, you may not see that in the raw video. But using softwares, we can still do that. We can still choose the best frames and stack them and get all the details together.
Right.
Thank you.
This
Thank you
this
for.
effect, even I also felt when I was observing that. So when I was starting photography and also observing with my home built telescope, I used to also feel that we can see more through our eyes than the camera. But then, as you learn more, I think the camera will definitely have more advantages.
So one more thing I observed while doing it, whenever I did a digiscoping, it was good. The frame was good, But when I was using my my camera adapter to a telescope and taking a photograph of DSLR, because my Barlow lens is almost on the higher side of my magnification, the photo is much blurry. It is not that clear. But when I reduce my magnification through my eyepiece and then take a digiscoping through my mobile phone, it is pretty sharp. This I have observed.
Ah, I see. So you're hitting the limit of the telescope itself, the quality of the image it produces, or even pH,
Yeah,
right?
so sometimes using a coma corrector helps. And also sometimes what happens is, since our cameras are usually heavy, when you put it on the focuser, the collimation may go a
Collimation.
little bit off.
Right. Yeah. Okay, that makes sense. I think that can be said true of the 31 millimeter Nagler eyepiece as well. The big one.
That's true.
Anyway,
But even with the 31 Nagler, if you look at the extreme edge of field, you can see some coma, right?
yeah, you
You
see a
can
lot
see
of coma.
some
In my scope,
distortion. Yeah.
especially the fast scope, you see a lot of coma in that eyepiece.
Yeah, so
Yeah.
the same thing will happen even with the camera. But what I have seen is, if you directly use the camera and then photograph and then use a coma corrector, the coma corrector makes a lot of difference.
Mm-hmm. Yeah, for photography, coma correctors are a good idea. I would avoid using them with visual observing just because more elements, but I know some visual observers who use them. So I don't fully understand why. I think there might be some trade-off there.
Okay, okay.
Anyway, so I'm now going to get into the storytelling part of this talk, which is roughly divided into three sections. And the first section is inspiring observers. These are people who I have come across or met who have published material on visual observing and so on in websites or articles in Sky and Telescope and so on, that I consider as very prolific observers. It's a very biased selection based on who I am acquainted with. So I'm sure there are many great observers that are not on this list here. But such is my acquaintance circle. That's about it. Then I'm going to go and talk about a few cool observations, observations that both I was part of and some that I was not part of, that I think are extremely cutting edge, if I may call it. Not many people would have made such observations, partly because of lack of equipment, but or access to equipment, but also because of access to good skies, and so on. And finally, I'll talk about my personal journey of 15-ish years now, 14 years in visual observing. So let me get started. So I wanted to I wanted to come up with my own version of Newton's quote. If I've seen painter, it is by standing on the ladders of giants. What I'm trying to say is that there's a lot of value in observing with a lot more experienced people than yourself. And it's only by learning from people with more experience than me that I've learned to see fainter objects. So at this point, I just want to put in my acknowledgement slide. These are the people who helped me in my visual observing hobby from the beginning. My parents are the people who first showed me Pleiades and Scorpius, and all the way, to people like Jimmy Lowry and Steve Gottlieb, who I've considered as mentors in this field, who are exceptional observers. I just wanted to, at some point, I have to acknowledge everyone, and this is my acknowledgement slide. So this is why you are able to hear me talk about visual observing. It's thanks to these people. And okay, so like I said, now I'm going to feature the work of some observers that have inspired me, and many of them have made important contributions to visual astronomy. It's not an exhaustive list by any means. It's mostly a biased list of people based on my interests and people I've come across or met. I think almost everyone in in the list of people I introduce here, I have had a chance to meet, except Alvin Huey, who I've corresponded with, but not met. So this is unfortunately is a very US and Germany centric list, because those are the people whose observations I'm aware of. There are exceptional observers across the world that I don't know about. So let me introduce my friend Jimmy Lowry. He he designed and had OMI build him a 48-inch telescope, which has really changed amateur astronomy, if I may say so. It's the cutting edge of the visual observing field, because what you can see with his 48-inch is incredible. And not only is it an incredible instrument, in fact, many people say that they get better views out of this 48-inch than professional 1-meter telescopes, simply because this is designed for an eyepiece. This is designed for a visual observing, and it's not designed for photography. So first of all, it's a very good instrument. Second, it's permanently stationed under really dark skies in West Texas. And third, it's in the hands of an exceptional observer. And it's surprising, that I think I've probably seen a handful of Messier objects on this telescope, because whenever I met his observatory, we are never looking at the bright things. We are always pushing the limits of what is really hard in a 48-inch. So so Jimmy is also an exceptional observer. Like I said, it's a combination of the instrument and the observer. He discovered an uncatalogued planetary nebula on Sloan digital sky survey images, and he named it the Sweet Pea, and he followed it up visually. So it's not typical that an amateur gets to discover an object these days. So that's something he has to his credit. I think one of his best lists out there that he has shared with other visual observers is a list of ring galaxies. He's a fan of ring galaxies, and he's observed a lot of them. The thing is, most of these ring galaxies in my telescope, I won't see the actual ring. There might be one or two that, whereas in his telescope, he can actually see the rings. So they actually look cool. Whereas for us, it's mostly faint fuzzy targets. Jimmy's logs and sketches can be found on the Deep Sky Forum, which I introduced a few talks ago. And Jimmy lives in Texas in the USA. This is the Astronomy Technology Today magazine did a cover article on his telescope when it was first installed. They had to have a crane bring the mirror and so on and so forth. More pictures of it later. So when you read Sky and Telescope articles nowadays, you almost see every article by Steve and Howard. Chances are there'll be a reference to what the view is in 48 inches. So this is a picture of Steve Gottlieb with his telescope, a 24-inch. Steve is an amazing visual observer. He is the first person to visually observe all of the NGC catalog. Not even Herschel did that, because he was one of the initial catalogers of the catalog. So the catalog wasn't complete. But I mean, so of all the NGC observers, I think Steve might be the first person to actually observe all of them. He is a contributing editor to Sky and Telescope. He has many articles on the website Adventures in Deep Space. And I've already shown you his logs. He sketches in words with his logs. And Steve's logs and observing lists can be found on Adventures in Deep Space. And Steve lives in California in the USA. Even before I came to the US or anything, when I was observing in India, Amar Sharma told me about Steve Gottlieb and Adventures in Deep Space. So we used to look at Adventures in Deep Space and know what is possible with a 17.5-inch. That's how we were able to push the boundaries back in 2009 when we started observing. We were able to learn from his logs. So I really encourage everyone, to look at his website. It's very, very, very rich with information and amazing objects. Okay, this is Howard Banich, whose sketches I've shown you a lot. Howard is exceptional at sketching. He is also an amazing telescope maker. That 28-inch that you see in this picture was built by him. He's also a contributing editor to the Sky and Telescope, so you'll see his articles in Sky and Tel. He sketched this amazing view of Messier 77 through Jimmy's 48-inch. This is the sketch he did over 4 nights, I think. And he also chairs this workshop called the Art as Workshop, which is pushing the frontiers of, if I may say, telescope making. So Howard is currently investigating how to silver telescope mirrors by spray silvering, so that you don't need to aluminize them in the traditional vacuum chamber and so on and so forth. So he lives in Oregon, USA, in Portland, which is a pretty big hotbed of amateur telescope making. Other than Stella Fane, I think that's the next place in the US that comes to my mind. And yeah, Howard's sketches can be found on his website. I encourage you to check it out. They're just really amazing sketches. This is Alvin Huey, who I've never had the good fortune of meeting. He has exceptionally deep and obscure observations on his site. His site has a wealth of information. Faintfuzzies.com is his website. Most importantly, he has created these observing guides with some of his notes, as well as 3 levels of charts. And people say he can star hop faster than people punch in the array deck into Argo Navis or any of these digital sitting circle systems. So he is a very good star hopper. And not only that, he has shared a wealth of information in terms of these guidebooks. Here I've shown a picture of his Shakbazian group's cover, but he has more tame guidebooks that are like Hickson's and so on, that are within the reach of a 16-inch telescope. So I encourage you to check his site out. This is Uwe Glahn, who is a German visual observer. He has his website where he posts a lot of sketches. He can see a lot of faint detail that blows the mind. He's able to see things in a 16-inch telescope that I just would have thought were impossible. He's done lots of really faint observations, mostly with a 16-inch telescope, and now with a 27-inch telescope. I think he has English versions of most of his work on the website. Some of it might be in German, in which case you could use Google Translate. He makes amazing sketches. Yeah, I had the good fortune of meeting with him in Munich, but I never got to observe with him. They observe in the Austrian Alps. I think I showed you their observing site earlier, and it's just, I'm told that the seeing there is really incredible. This is Frank Richardson, who is also from Germany. He lives in southern Germany. Uwe and Frank observed together quite a bit. Frank recently upgraded to a 36-inch telescope, which I think might be the second biggest telescope in Germany. And he's making a lot of very good sketches and observations from this. Some of his observations are actually in my favorite book, the Wolfgang Steinicke and Rick Jekyll book on galaxies and how to observe them. So if you see Frank Richardson's logs, this is Frank. He also scouts out special observing sites with exceptional conditions to make these observations. Some of the German amateur astronomers are so serious that they actually travel all the way to Namibia in Africa for the southern skies. And Frank, unfortunately, does not have his own website, and some of his sketches and logs can be found on his friend's website. So that's Frank. Mel Bartels, who I've mentioned many times in the last few talks. This is Mel Bartels. He's very well known as a telescope maker, and he used to write for the Sky Telescope, if I remember right, on telescope making. But he's also a very good visual observer. And I've shown you a lot of his work: low surface brightness objects and integrated flux nebulae, and all of these really faint nebulosities. He organizes telescope walks at the Oregon Star Party, which are famous. He goes around and various telescope makers show what they have done and how they might improve it if they had a chance, and so on and so forth. It's a discussion on telescope making, and he's also working with these cutting edge meniscus mirrors. And trying to make telescopes that are lightweight out of them. So you can carry an entire 36-inch mirror in your hand, like he's doing in this photograph. I think that might be a 30-odd-inch mirror. And his website is full of his amazing work. I highly recommend checking out his website. This is Larry Mitchell. Larry Mitchell is well known for his 36-inch at the Texas Star Party. And for the Texas Star Party Advanced Observing Program. The Texas Star Party Advanced Observing Program is a gold mine of amazing visual observing targets. And if you actually go to Texas Star Party, he gives you a pamphlet with a wealth of information on each of those objects. But even if you can't go to Texas Star Party, the list of objects is available on his website. On the Texas Star Party website, and those lists of objects are just absolutely incredible. I mentioned them before as well. Larry Mitchell is also famous for creating the Mitchell Anonymous Catalog. He actually went and gave names to, or gave catalog numbers to then uncatalogued galaxies on pause plates. And he created his own catalog of these so that amateur astronomers could refer to them. Before, I think they all had LIDA or SDSS numbers. And the other famous thing that he's famous for is the Ain't No Catalog. This is something that Amar showed me for the first time. The Ain't No Catalog is a thing. Is supposed to be a joke of the most impossible targets for visual observing, and yet people have actually checked out a few items on that. It's just mind-blowing that people have been able to observe things on that catalog. That was supposed to be a joke. He, till this day, star hops with uranometria. His telescope is not motorized. I think it might have tracking, but he doesn't punch in into a goto, he star hops. And that too with uranometria, no software. Larry lives in Texas in the USA. I don't think he has a website, but you can see his lists on the Texas Star Party Advanced Observing Program. This is the Ain't No Catalog. It has crazy things like, it's on Adventures in Deep Space. You can find it there. And it has crazy things on, like observe the sunspots on Rigel, or observe footprints of the moon. Some of them are just clearly jokes. Some of them are actually possible, and people have observed them. So this is something fun worth checking out. The other person who contributed to the Ain't No Catalog was Barbara Wilson, an amazing visual observer. Unfortunately, she passed away last year in 2019, October. She used to be one of the most respected observers in Texas and a regular attendee of the Texas Star Party. And her specialty is globular clusters. You can see her work on Adventures in Deep Space. So Adventures in Deep Space is not just Steve Gottlieb. It has observing logs from many good observers and lots of good advice, including Barbara's work on globular clusters. So that's a profile of everyone. This is a bunch of amateur astronomers all at Texas Star Party. Many of the people that I just introduced are here: Larry Mitchell, Steve Gottlieb, and so on. So Texas Star Party and the California Star Party are generally where most of these people observe. Okay, so those are my sources of inspiration. I cannot recommend Adventures in Deep Space enough as a website. So let me go on and discuss some cool observations, some of which I was part of, some of which that I was not part of. This object is called Hani's Woolworp. It's a very unusual object that they call a quasar ionization echo. So here's a galaxy. Oops. Okay, here's a galaxy, right? And the light from that galaxy is hitting some gas. It's an active galaxy, so it's a very bright core. The light from that galaxy is ionizing this gas, and it's emitting oxygen-3, and we are seeing that oxygen-3 light. So it's named after a Dutch school teacher that discovered it in the Galaxy Zoo project. And then professional astronomers followed up on it because it's such an unusual object. And Jimmy Lowry actually has observed it. Many people have seen it on Jimmy's scope. I think this is the object, and this is the galaxy, right? So the object is just above the galaxy here. So this is Jimmy's sketch of the object. I have not been fortunate enough to observe this yet. The amazing thing about Hani's Woolworp and many of these AGNs that have light echoes like this is that our traditional O3 filter will not work because the lines are redshifted. So this ratio of the change in wavelengths to the wavelength of the O3 is about 0.05, so 5% difference. And that's enough to get it out of the filter, right? So you can't, if you put an O3 on this, even though the emission is actually O3 because it's redshifted, you won't be, the O3 filter will actually darken it rather than improve the signal to noise. So they managed to get some boost from an obscure filter, wideband filter, and they managed to make this observation on the 48-inch. Here's another crazy object. This is called Einstein's cross. It's a gravitational lens. In the foreground is the lensing galaxy called I think Huxa's lens, which is visible. It's not so hard. In the background is a quasar that's 8 billion light years away. That forms 4 images because of this foreground lensing galaxy. And this is a very tough object. People have seen it in much smaller aperture, but we struggled to see it in a 48-inch. At least I struggled to see it in a 48-inch. It's a very seeing limited observation, so you have to have that good air that I was talking about, the steady air. And I think I managed to see 3 points, 3 out of the 4 images when I went up on the 48-inch ladder. It's a challenge even in the 48-inch, and this is my observing log. That's one crazy object. Here's another crazy observation that we made both on Jimmy's telescope, which is a 48-inch, and Steve Gottlieb's 24-inch telescope. This is a very extreme globular cluster that was discovered only in 2015. So it was just discovered 5 years ago, unlike most NGC objects which were discovered by Herschel long ago. So there's a little bit of fun to be able to visually follow up something that was discovered only as recently. This was discovered on Pan-STARRS 1 survey, which is a new sky survey. And here's the globular cluster. We were able to see this both in a 48-inch and in a 24-inch. So this is my log from 48-inch. I say quite easy. I mean, sure, exceptional telescope, exceptional skies. But yeah, it's a tough object. I think I might be able to see it in my 18-inch if I tried on a really good night. So this was in 2016. So see, we followed up just within a year. So that was fun. Another amazing observation that we made was a lensing arc in 2150 in this cluster Abel 2152. So gravitational lensing arcs tend to be these extremely blue things. I don't know why. And even the brightest ones, nobody has been able to observe them. And I think this is the only lensed arc that we have been able to observe. And that's because I think the galaxy that is lensed is only 1.8 billion light years away, whereas the foreground galaxy is a little closer, 580 million light years away. So it's nearby by standards for these typical lensing arcs. So here's Howard Banich. Here's Howard
Sorry,
Banich's sketch.
in the
Yeah.
previous one. So what do you mean by the lensing arc? I didn't understand. What exactly are you referring to? Are you referring to the galaxies or?
Okay, I'll pull up a picture. Let's see, lensing arc of. Yeah, so this is a typical gravitational lensing arc, right? Where the background galaxy is so badly lensed that it gets stretched into this circular arc. It's an extremely challenging. Most of these targets are extremely challenging. I don't think anyone has been able to see them, except in this one case. There's a really tiny. So this object here. Sorry, I forgot to highlight it. See how it's stretched out like an arc.
Yeah,
it's a galaxy, a background galaxy that's been stretched out like an arc because of gravitational lensing. And it was a really tough observation on even the 48-inch because I think this is close to 20th magnitude, if I remember right. But we saw it because we had exceptional conditions on that night. Howard Banich made a sketch of it. So this is his sketch of the arc. He even saw it elongated. I don't think I managed to see the elongation, but Howard said he saw it elongated. So that's really amazing. Now more pedestrian objects, but still amazing observations. This is a interacting pair. I think it's in the art list as well. It's an NGC object, NGC 6621. I love this object because the detail that I managed to see in Jimmy's 48-inch, which is the first time I saw this, I think, it was spectacular. It was just like a photograph. And here's Howard's sketch. I think this might be with his 28-inch. He's picked up both the cores and so on and so forth. But I managed to see a good amount of this tidal tail even in my 18-inch. So you see this is it's rotated by 90 degrees, but that's the tidal tail that I managed to see. And I also saw the cores and things. So I love this galaxy because it's very unusual and it's even accessible in my 18-inch. So now, are there challenging objects in a 48-inch? Here's another example. This thing called the violin clef is extremely difficult. I believe this is Steve's observation. Or is it mine? I don't know. But okay, yeah, this is not Steve's observation. This is my observation because it doesn't have as much detail. So yeah, this was a real challenge. I don't even remember observing it, but that's why logging is helpful. Yeah, there are objects which are really impossible in even a 48-inch, and I don't think we were able to see these tidal tails on that night. So there we go, crazy observations. How much time have I taken? About an hour. I'm just going to briefly go through my personal anecdotes. Yeah.
Before we go forward, so there was a question as to how people actually I mean, people use GOTO on these big telescopes, or do they point to the object on their own?
So, like I said, Larry Mitchell, which is 36-inch, completely pushed to. He points to he star hops to the object. But most of my other friends, they all punch in. They all use GOTO. Jimmy Lowry controls his telescope with Megastar software, and Argo Navis, he has his own custom built 80K encoders on the axis of the telescope. They are still not 100% accurate, so he still has to do the last bit of star hopping. He has a way of trying to think on a nearby object and so on and so forth. But Jimmy uses GOTO. I think Howard also uses GOTO. Howard, however, has a slip clutch, which means that he can also push his telescope. And when he lets go, it just keeps tracking as if nothing happened. And Steve uses GOTO. Yeah, most of the visual observers I know use GOTO, except I think Alvin Huey and Larry Mitchell. These people star hop.
So all these telescopes are on an equatorial platform, some kind of equatorial platform, but this equatorial platform also has okay.
No, almost all of these telescopes are on alt-azimuth tracking systems. So the thing is, both the alt axis and azimuth axis are driven by a friction drive. No, the azimuth axis is driven by a friction drive. The altitude axis is either driven by a chain or it's driven by roller bearings, basically rolling the alt bearing. And the software computes the rotation rate on the two motors, depending on the encoders. So the encoders tell you do 2-star alignment or whatever. The encoders tell you where the telescope is pointing, so you get an alt-az estimate, and the tracking rate is adjusted based on that.
Okay, got it. So that is why with the clutch, even if you manually reorient the telescope, because of the encoders, the telescope still knows where it is pointed. Okay,
exactly. Then because of the encoders, the telescope knows where it's pointed, so the computer will recalibrate the alt and azimuth drive rates.
Mm-hmm. Okay. Thank you.
Akarsh, I had a question.
Yeah, sure.
Yeah, so since we were talking about encoders and you said that he uses 80K encoders, my question is, why is it required to use something so highly accurate? I mean, 80K is what would be the accuracy level down to arc seconds when you're using something like 80K, and do you really require it with such big telescopes?
So I think it's not so much about. So I think the idea is to just eliminate the DSE least count from the various errors you can get.
Okay.
I think if he builds a flexure model, I'm told he gets like very good pointing. So it's not about arc seconds, but arc minutes make a difference. You want to be within 2 or 3 arc minutes for many of these faint objects.
Okay.
So for that reason, you need at least like 4K, right? Or depending on how you read them. But I think in Jimmy's case, it's mostly to just remove that as an error factor. I'm not very familiar with why he chose 80K encoders, to be honest.
Okay.
Have you tried to observe planets through these big telescopes?
I think there was one cloudy night when we saw Saturn through Jimmy's telescope. That might be the only time we've done that. That was our first time. It was cloudy at Texas Star Party, and Santosh was there, and so I had to take him to Jimmy's. That's how I met Jimmy, actually. And because Santosh asked, he said, there's a person with a 48-inch. I would really love to meet him. So I wrote to Jimmy. and Jimmy was very welcoming. I didn't expect that initially. He's a really chill guy. So we went up to his observatory, and that was the one night we observed Saturn. It was through the clouds, so I don't remember very much. Then the transparency and seeing and all of that, right? You don't get a very good view through the clouds.
Okay, yeah. Thank you.
Okay, so I'll just share some personal anecdotes. This is mostly my journey. And the reason this might be interesting to you is because they're 48-inch pictures. So, and star party pictures. Here's my very first telescope, 8-inch made at ABBA. Thanks to Dilip Kumar and Vijay Kumar. And Prakash Subarna gave me this idea that now that I've made a telescope, I should see all Messier objects with it. And so I set a target saying I'll observe all Messier objects in 1 year. And I almost made that target. I think there was one uncertain observation, but 109 were certain observations. And by 1.5 years or so, we were so crazy. After my board and entrance exams, Amar and I went observing for 2 weeks, alternate days. We would go to the village, set up. We had already kept the telescope there, so we set up, observed, put the telescope back, and next day we take the bus and come back, sleep, and then the next day we would do the same thing. We would go again. So by the time I managed to find the logs. So the most useful thing there is I don't remember what objects are visible in the city. But I did a lot of city observing back then. And so the logs actually tell you which objects I managed to see from the city. So that's useful for you folks. This is the first light of the 17.5-inch. Amar had no idea I was showing up. This is Amar Sharma, who was my very first big mentor in visual observing. Amar had no idea I was going to show up to the observing session. I had given him some excuse saying I won't show up, and he had gone away to get the telescope from inside the storage. And by the time I had started setting up the 17.5-inch, and I still cannot forget the shock on his face, the excitement that we had that night, for the first time viewing all these objects in great detail. That was really something. And by the end of 2009, we had done our research on, to be honest, adventures in deep space. So we had read a lot of Steve Gottlieb's notes with his 17.5-inch and figured out what was possible, what was not possible. So we pushed ourselves, and these are some of the observations we made in Coorg. Then we had exceptional skies. Kirti was there that night. So here's Horsehead Nebula on the left, and a sketch of NGC 891 on the right. I didn't make these sketches on the field. I think I tried to remember as much detail, except maybe Horsehead might have been done on the field. I wish I had done these sketches on the field. Anyway, then eventually in 2011, after I moved to the US, I bought my current telescope secondhand from my second big observing mentor, John Tatarchuk. John was somebody I got introduced to on cloudy nights. He was answering all my questions. And I found out he was in the same place where I was going to go. So I ended up meeting him and then eventually bought his telescope. This is a recent photo with my current telescope. This is my pics from my first time at Texas Star Party. This is Larry's 36-inch telescope, which he star hops with. You can see a lot of big daubs. Texas Star Party has a lot of big daubs. I think my 18-inch was probably the 25th or 30th biggest telescope in this place. So Amar had told me about Texas Star Party. That's how I knew about it. And I was very happy I was going to Texas for that reason. This is Jimmy Lowry's observatory. That's the 48-inch. The ladder is really scary on the top rungs. And Santosh went around and took this picture of me on the ladder. That's how big the telescope is. This is the mirror of the 48-inch picture by Santosh. It's an Astrocital mirror. I think it has some amount of coring also, and he has lots of fans at the back, which he turns on for removing the tube currents. Eventually, I got introduced to Jimmy, and Jimmy and I became good friends. And in 2014, I learned that Steve Gottlieb was coming, and I always wanted to meet Steve Gottlieb because I had read his logs and followed his logs as a youngster, right? From Adventures in Deep Space. So finally, I got to meet Steve Gottlieb and at Jimmy's observatory, and got to observe with him. And then lots of nights at this 48-inch because I lived 7 hours of driving away from Jimmy's place, and every now and then at new moon I would start setting. I would say, okay, let me take my telescope out, and I would get a call from Jimmy saying, "What are you doing this new moon?" And I would drop everything and just go to his place and observe with the 48-inch. So on my 27th birthday, I showed up at Jimmy's place, and it was just Jimmy and me, which is unusual in May because Texas Star Party brings a lot of people to his observatory. And he asked me, "You have a 48-inch at your disposal, and you didn't come with a list." I just did not take a list. And that's why, I mean, remember I said you should always have an observing list. Thankfully, Jimmy has very good lists. So I'd much rather observe Jimmy's list than my list. And this is an arc galaxy interacting pair. You can see how the telescope pretty much shows everything that the image shows visually. This is one more from the same year. This is an arc pair that we sometimes call the heron because it looks like a heron bird. And I was again at Jimmy's telescope for my 28th birthday in 2016. And so we saw, this time I think there was a group of people from Texas Star Party, and we saw a lot of great stuff, including really faint galaxy clusters. This is Shakbazian 154. And that's when we saw this amazing NGC 6621. This memory is kind of etched. You know, some of your observations you remember, and for me, this is definitely one of those observations I remember because almost every bit of that photograph was visible in the eyepiece. In 2019, more recently, Jimmy scouted this place which was in the middle of nowhere in California, in Northern California, and at 9,000 foot elevation. It's in the middle of the largest black zone that's bottle one skies in the US. And so after Golden State Star Party, which is California Star Party, Jimmy and I went there with my 18-inch telescope. And the roads were very interesting, very rough roads, but I said, my car can handle it. And we went and we tried to figure out how to observe in this place. We had mosquitoes, we had all sorts of problems that we never imagined. But then this happened. This is Corona Borealis cluster. And Corona Borealis cluster of galaxies is normally called lumpy darkness because it's very, very faint. And when you just look at the eyepiece, you just see as if the background, sky background is a little mottled. You can't make out the individual galaxies and things like that. But we had such good sky conditions that in my 18-inch, we counted 9 galaxies without even trying very hard. They were just all there. And the brightest 4 galaxies were easy. We just held them 90% of the time, averted vision. That basically says that, sky conditions matter a lot. And we were under some of the best skies. Even though we had some problems, we didn't have the best humidity. I think it was pretty humid where we had set up. But great skies go a long way, even in small aperture. Great skies will any day, in my opinion, defeat aperture power. So this is one example from the recent times. That's it from my end. Big thanks to Kirti and Vishwanath for organizing all of this and giving me a platform to share this. And big thanks to everyone participating for your sustained interest and all the questions. I've had amazing discussions. So thank you for joining me. Now I will pause for questions. And after this, I want to bring Sanat and Karthik on to present, and they will talk about their trip to Hanle for visual observing and what they learned from it. So this is kind of how to push the limits in the Himalayas, right? The best skies probably that exist in the world. So let me pause for questions, and I'll stop presenting. And yeah.
I can ask any question. You're able to hear
me? Yes.
Yeah. So okay. Anyway, I put it in the chat. So I think last week you have shown a drawing of Andromeda galaxy, sketch of Andromeda galaxy by Howard Bench, where he was able to see a lot more detail than a photograph, right? So earlier in the discussion, we were having this high dynamic range, but the photograph should have captured, right? But you said something which I could not get it last time.
I still fully don't understand that sketch. But multiple observers, both Uwe and Howard, have sketched the same thing. So I still haven't figured out how to map that to the image and what they are seeing. But somebody pointed out there's a thread on Deep Sky Forum on this. And I think somebody pointed out that it might be the fact that some of the features are in green, and that green is very easily visible to the night vision. So it might not show up as brightly in photographs, but will be visible in our night vision. The other possibility is that you just need much deeper exposures. And when people process their images, they don't pay attention to that maybe. Now, I know Rogelio has a picture of Andromeda galaxy with a lot of clouds, but he took that with H-alpha filter. So those cloud patterns will not agree with what Howard or Mel Bartels have seen. So I don't know exactly what it is. I'm also trying to figure out and try to reproduce that observation if I get chance to access to such good skies. But how, I think there's a thread on Deep Sky Forum, and I still did not understand how to correlate that 100% with the picture.
Okay, so let me go through that in this.
Yeah, forum. If you figure out something, please let me know. I'm very curious about that myself.
Sure, we'll do that. Thank you.
Where did I see this? Yeah, any more questions? Any more comments?
I think Leela ma'am wanted to ask a question. Go ahead, Leela ma'am. Okay, I don't know what happened.
Kirti, Leela ma'am's question is on the chat actually. If you can read it out, perhaps.
Okay, all right. So how does, Leela ma'am asks, how does one know what are the details to look for when for a beginner for a beginner who is really new in deep sky objects? Until you pointed out, I didn't even know what you were talking about.
Okay. So my best answer to that would be try to look for people who use your aperture, who are more experienced visual observers, and try to see their logs and sketches and learn from them. That would be the best way.
No, I'll just see. Can you hear me now?
Yes, I can hear you now.
Okay. No. See, when you were pointing out actually to that, when Kirti also asked that question, you're pointing out to gravitational lensing, and we're talking about the arc Those are
Yes.
really deep sky stuff, which I probably will never, I don't know, in this Janma whether I'll see it. But I was curious to know, how do you know it was, how did you know it was gravitational lensing? I mean, what are you,
Ah,
what is, is it from Hubble or is it from, I mean, how do you know what you're looking for?
okay. So in the specific case of the gravitational lens, I think somebody found it in a research paper and said, all of these extremely serious visual observers like Uwe, Jimmy, and Steve, these people actually read research papers, and they might not have a full background of the math and physics or whatever necessary to understand the full depth of the paper, but they learn about cutting edge objects and what is happening in astronomy all the time. I wish I could do that. So they came across a research paper that described this gravitational lensing. And so I have access to that paper, and I'll share it. It's on the archive. I'll share it on the Google group after this talk. And it's mentioned in that paper that this particular object pointed to by the arrow A in that photograph is a gravitational lens, and they have measured the redshift, and that's how I know it's that paper that I'm quoting the redshifts from, the distance and redshifts.
Okay, because when you said arc, I only saw the galaxies till you pointed out the little portion,
I'm
which
sorry.
I didn't even realize that is what you were actually pointing out at. Sorry, because I'm
my fault for not pointing it out. I remember I think I had planned saying that I will circle it, and I'm glad Kirti corrected me. I'm sorry, I should have pointed it out. The only way we knew that was a lensing arc is because when you look that picture is from that paper, and when you see that paper, he says that A is a lensing arc.
Okay. Thank you, Akarsh.
Sure.
I just want to add, so what the Einstein cross, the stretching of the galaxy and all, there are nice articles in Sky and Telescope, I think, which come very occasionally. Every few months, you can see something new there. So this is probably another source of, there is something there. So I remember asking Subhankar whether he was able to photograph Einstein's cross one day. So he said he has never tried that.
I think it will take exceptional. I think it's a very tiny object, so I imagine you will need a RC 16-inch kind of telescope. But I could be wrong.
Yeah, you might be right.